All right. Hi, everyone. Thank you for coming. For the sake of the camera, this is a joint San Francisco MySQL meetup group and San Francisco PHP meetup group. We're combining the groups tonight to hear Justin Swanhart talk about Shard-Query, an MPP database for the cloud using the LAMP stack, as you can see up on screen. For those of you that have asked me many times tonight, and I keep forgetting to look it up again, MPP is massively parallel processing. So that'll be really interesting. I've been meaning to take a look at this for quite some time, and I can't believe I haven't. Anyway, we have lots of sponsors tonight. We have Percona. They are providing, woo!
Woo! Oh, I'm liked. Sorry.
Justin's time. They provide a lot of our food. They provide books, speakers, raffle tickets, or not raffle tickets, but like raffle prizes like Percona Live tickets, all that kind of fun stuff. Also sponsoring is Lithium. They provide my time, Darren's time, food, the facilities here. This is our first time in this new room, I think, so we put a lot more stuff into here. We also have Engine Yard, who's sponsoring the PHP group. They are working on our logo, which is, I know we said this last time, just about done, but it is getting there. And as always, O'Reilly. We have a bunch of O'Reilly books to raffle off as well tonight. We got a bunch of t-shirts we'll give away as well. The books and stuff, the little pamphlet ones back there, help yourselves, have at it. What else we got going on here? Lots of announcements tonight. On Monday, August 4th, the PHP meetup will have a PHP 5.new, the best bits. Davey from Engine Yard, he'll be giving that talk, and that'll be down at Engine Yard, which is kind of back towards the IGN area, but not quite as far. And then Tuesday, August 26th, here at Lithium, we have Jeremy Zawadny from Craigslist. He'll be talking about real-time search infrastructure and the architecture that they use at Craigslist. Really good talk. All of his talks are great, so highly recommend coming out for that. Also, so quick thing for the PHP group, we've ordered a whole bunch of the PHP Architect elephants, so those have shown up, and so didn't quite get ready with those for tonight, but we're going to be, for those of you that weren't able to get the run for it, we're going to try selling off some of those as a bit of a fundraiser for the group to help get some of the equipment for the different facilities when we go to different places, and just the different gear that we need for here, raffle prizes, all that kind of fun stuff for the group. So more information about that will be coming out in the next week or two. Let's see. Aaron, am I forgetting anything? What's that? No? All right. So as usual, anyone here looking to hire people? All right, we got a few here, over there. And for those of you that are looking to be hired, those are the people to go check out. Hit them up, and you know, hopefully some connections will be made. Woo! And with that, I'm going to go ahead and turn it over to Justin.
Okay.
Oh, and cell phones off, please.
So this is Shard-Query, an MPP database for the cloud using the LAMP stack. I'm going to go through some terms here at the beginning, so if you're not familiar with what MPP is or whatnot, don't worry. I'll cover all the acronyms. So I'm Justin Swanhart. I work for Percona. I'm now a principal support engineer at Percona. In the past, I've been a consultant and also a trainer. We are hiring, so if you raised your hand to say that you're looking for a job, talk to Ryan Lowe, and he can point you at the right person. So Ryan's right back there in the San Francisco hat. So I develop a bunch of different stuff, not just Shard-Query. So I've got Flexviews, which is a materialized view solution for MySQL. And for those of you who are doing scientific work, I also have BC Math UDFs, so you can use arbitrary precision math in MySQL. So like POW, 1027 digits, no problem. So if you're here, I hope that you fit in one of these groups. You're a MySQL user that has too much data to fit into a single machine, or you've got big data, which is kind of synonymous. If you're doing analytics, OLAP type querying. If you've got a big database like Facebook and you want to count how many posts people have made or how many different tags they've had, all that kind of stuff, user-generated content analysis is great. Or anybody interested in distributed database processing, right? So ShardQuery implements a distributed layer on top of MySQL. And this set of slides isn't incredibly long, so we have plenty of time for questions and answers at the end. So it's, tell you the truth, my thumb drive that had my slides on crashed, so I had to recreate all of my slides really fast in the last 2 days. So if I miss something, I'll come back to it at the end. So what's MPP, right? MPP is massively parallel processing. An MPP system is one that can spread queries over lots of cores or over lots of machines over their cores. So spread the work out. You're going to scale out instead of necessarily scaling up. But ShardQuery does help you scale both up and out, as we'll get to. Now, MySQL Fabric and other sharding tools, they all operate on what's called a grid, right? So the idea is we're going to put a bunch of computers together that all have the same schema. They all have different data, right? So if you're Facebook, for example, you're going to have lots and lots. They have 5,000 shards, where a subset of users are on each one of those databases. And they all work together as one big virtual computer. So sometimes MPP is also called grid computing, Oracle 10G, grid. So not many open source databases, really none, support massively parallel processing queries. It's something you have to pay a lot of money for in general. So there is some open source, or closed source, Vertica, Greenplum, Amazon Redshift. These are all closed source databases that do MPP processing. But they don't do sharding, so we'll talk about that. The cloud, right? We all know what the cloud is. The great thing about the cloud is that you can easily spin up or throw away machines. And so you can add new nodes over time as your amount of data increases. So you add servers on demand. Federated distributed database is easy to create, well, relatively easy to create in the cloud because you can add more machines. Or you can go to a machine that has more cores. So you can scale up or you can scale out. And Amazon is one of the most popular cloud environments, probably the most popular. So Amazon AWS is what we use typically with ShardQuery. So the LAMP stack, I'm sure you're all familiar with LAMP. Linux, Amazon Linux, RHEL, Ubuntu, it doesn't really matter as long as it's a good Linux. The Apache web server, Apache is not required to use ShardQuery, but it does have a web interface that you can hook up to use through Apache. Of course, MySQL is the world's most popular open source database. And there aren't a lot of sharding technologies available out of the box for MySQL. There's pretty much ShardQuery and MySQL Fabric. And MySQL Fabric is still new, and it's OLTP oriented. You have to modify all of your queries in order to use Fabric, but not ShardQuery. ShardQuery understands the distributed nature of the database and sends queries to the right place. And of course, PHP. PHP is a high-level language. I was telling Ryan a little bit ago that ShardQuery is about 10,000 lines of PHP. And it could be written in Go or Ruby or whatever you really wanted to, but I like PHP, and I get to develop really quickly in PHP, so it's what it's written in. So ShardQuery is middleware, right? It sits in between the database and your application. You send queries to the middleware. It does the distributed query, gets the results back, and hands it back to your client, right? So this is usually a proxy of some sort. MySQL proxy is open source, and it's what ShardQuery uses. There's also MaxScale, which I haven't really investigated yet. MySQL proxy is nice because it has these Lua scripts. So the proxy integration for ShardQuery is actually very, very simple. It's one Lua script. It's like 100 lines of code. And it allows ShardQuery to interface with Gearman. So ShardQuery comes with MySQL proxy support right out of the box. So if you want to have a transparent database, transparent access, you can do that. One of the differences between regular MySQL proxy and this Lua script is that some of the commands, like if you do an insert, they'll come back with a result set. And it'll say that so many records were inserted or deleted or updated or whatnot. Because the sharding layer in the background, one insert might insert into 30 different servers. So it has to tell you that the insert came from or went to the right place. ShardQuery uses a message queue to do all of the communications, right? So message queues accept jobs or messages, put them in a queue, message queue. Some worker comes along and reads that job back out. It does some work, and it sends the results back. The really nice thing about Gearman is that it has asynchronous jobs. So you can kick off 20, 30, 40 different jobs, and you'll get the results back when they've all completed. There's a callback, right? So I really like Gearman. It's my job server of choice for PHP. It has both pair and PECL interfaces, but ShardQuery comes bundled with the Gearman library. The reason is that it's old, it's still alpha in terms of PECL, pair quality, and so I just bundle it so you don't have to install an alpha component. And I've made a few just minor modifications to the Gearman layer to get rid of warnings on new versions of PHP. PHP 5 warns about a lot of stuff that PHP 4 didn't, so it's a modified version that comes with it. The other nice thing about Gearman, and if you haven't used Gearman, you really should check it out, is that it has MySQL UDF. And this is the way that ShardQuery communicates with Gearman when using the proxy. It sends a command to Gearman through the UDF. UDF returns the results back as JSON, and that then sends it right back to the end client. Right? So it's very, very convenient. Who here has heard of sharding? Right. So it's a portmanteau that's short for shared nothing, or at least that's what I believe it is. That might be a backronym, actually, but sharding stands for shared nothing. So you're going to split your data up into more than one machine. You're not going to have one big database with this huge 300 gig table anymore. You're going to have 10 machines that each have 30 gigs of data, right? So then that's 10 times faster if you can access them all in parallel. It's important to know that just like Fabric, the lookup tables, the short tables in your schema, are not sharded. Right? So they're going to be duplicated on all of your nodes. MySQL Fabric does the same thing. This is what lets you do joins, right, in a shared nothing manner. So there's the lookup tables, or the dimension tables as they're often called, are going to be duplicated on all the nodes. And ShardQuery takes care of that for you. When you insert into a table that's not sharded, it knows that the table's not sharded, and it sends the query to the right place. And the way that it knows that the table is sharded or not is based on what's called the shard key. Right? So the shard key maps where the specific data is on each server. So if we're sharding by blog, right, blog ID 30 is on machine 1, and blog ID 40 is on machine 2. Right? So whenever we say select count star from blogs where blog ID equals 30, it knows to go right to the one specific machine. If we don't have that where clause, we just are counting things, it's going to go to both machines, and the results will get put back together. So there's directory and hash mapping support out of the box. If you want to be able to add or remove shards, you have to use a directory mapper. Directory mapper says that customer 30 is on shard 3, customer 31 is on shard 4, customer 35 is on shard 5, etc. Right? This allows you to move records from one shard to another as well. So if customer 30 suddenly gets 10 times bigger than all other customers, you can move them to their own shard and just update the directory to point the data to the new machine. Hash-based mapping, on the other hand, is a fixed hash. It's like using a partition by hash if you're familiar with MySQL partitioning. You can't add or remove nodes to a hash partitioned system because that would change the hash calculation. You have to redistribute your data over the whole set of machines if you want to add a node. Hash-based is faster because it's a mathematical computation to figure out which node the data is on versus having to actually go look up in the directory where that record is located at. Now, once that lookup happens, it'll be cached, so that's not so bad, but it still takes overhead to look up from the directory. So, I mentioned big data a couple times. What is big data? In general, we're talking about machine-generated data or user-generated data. If you're Facebook, user-generated data is all the posts that people are making on all of their walls. If you're machine-generated data, it's more likely information from an automated system, like a sales order system where you're keeping track of the line items for all of your sales. Right? Walmart is big data. Right? They've got 1 billion customers, each buying tens of things a day, so they generate a tremendous amount of data from their sales system. Essentially, any data that's so large that it becomes difficult to manipulate it on a single machine is generally something you're going to want to think about sharding. Right? So, example here I have, and this is a real-world example. Company has a star schema doing OLAP analysis using Mondrian. Their important query that they run every day for their sales information, how many sales per department or whatever, takes a very long time to run. And the more data they add to the system, the slower that query gets because it's doing analysis over all the data that's been added into the system. So if you're doing year-over-year analysis, for example, the current year might be growing faster than the previous year. And so you're just generating too much data. Eventually, let's say you want to run this query every 24 hours or every few hours or whatever, it gets so long that it no longer fits into your window. Right? You want to refresh it every 4 hours, but it takes 6 hours to run the query. Well, that's not going to work. So you've got to split the data up. This is really common for things like user activity logs. So when I worked at an ad serving company up here in the city, we used to log every hit and click of every ad that came through the system. Well, this was generating about 10 gigabytes of data a day. And putting that all into a single machine, it's going to run out of space, it's going to run out of CPU, and it just wasn't scalable. So we had to split it up and work over multiple machines. And that's where the impetus for ShardQuery was originally born out. Also, I said I was a trainer at Percona. One of the things that are part of the Percona training course is talking about sharding. And I used to spend about an hour talking about all the things that you couldn't do when you sharded. Right? You can't do a count over the entire set of machines in most sharded environments because they don't understand how to query all the different machines and put the results back together. Right? So MySQL Fabric, which is MySQL's sharding layer, it has no way to do a count over all of your shards. Right? You have to do that manually. So basically, aggregation queries are what we're talking about. ShardQuery is focused on OLAP, not OLTP. Not short transactions that read or write small amounts of data, but bulk loading and reading lots of data in a single query. A count star over a billion row table, for example. Now, I always say that ShardQuery is for OLAP, not OLTP. And that's because most OLTP systems have a requirement of 3 or 4 milliseconds per query. But because ShardQuery has to parse the query, it has to send it to MySQL to get information about the tables that are accessed and everything else, there's more overhead in running a ShardQuery query. So about 20 milliseconds is about the minimum latency that you can get out of ShardQuery. And that's more than enough for most people, but some people say that they can't do that. They have to have 2 or 3 millisecond queries, and that's not what ShardQuery is for. So, what's the big problem? Why does ShardQuery exist? Well, mostly because of single-threaded queries. So the big bottleneck when you're doing analytics is really reading all of the data. And using a single core, it's going to take a long time. MySQL, Postgres, Firebird, all the other major open source databases have single-threaded queries. I'm not aware of any open source databases that do multi-threaded queries. So a single query can only use the resources of a single core. So even if you have an 80-core box, and those are out there now, you can only use one single core while answering any one query. This is great for OLTP scalability. You can send hundreds or thousands of tiny little queries at the database at once, and it can spread them out over all those processors, and that works great. But not OLAP. OLAP is one big query that's counting thousands or millions of rows, and it's not going to be able to utilize any more than a single core. So the problem here is that your queries get slower and slower and slower as your data grows in size. In memory, the speed decreases because the data is accessed in a single query. When we're talking about I/O, that can be a problem too. So MySQL was optimized for getting small amounts of data. It's optimized for OLTP. The reason being is when it was created 13 years ago, there weren't multi-core systems. Right? There were only single CPU systems. And if you were a big business, maybe you had a 4 CPU system, right? But that's not the case anymore. Like I said, we have 80 core machines these days. Adding parallelism to the existing database is kind of not going to happen, right? We saw how long it took just for MySQL to get better subquery support, right? It took 3 versions to get better subquery support, and that's still not perfect, right? So they're not going to be changing MySQL to make it multi-core for a single query anytime soon. So like I said, it's designed for running lots of small queries at the same time, not one big query. Single threading is also bad for I/O, right? If your data set is larger than RAM, then you can get buffer pool churn from a single-threaded query. If one big table and a bunch of small lookup tables, scanning the big table and filtering out rows pushes the dimension table's pages out of the buffer pool. And then it goes and reads the dimension row and has to do I/O. And then it throws it out, and then it goes back and does I/O again. And this churn causes your query to run very, very slowly. Now, SSD can, of course, help that somewhat, can mitigate that problem, but you're still not going to be able to read from your SSD at the full rate that it allows, right? Because your single-threaded query is also like doing the sum and account and reading from disk, right? All in one thread. MySQL does not have the ability to use the read threads during normal queries. The read threads are only used by read ahead. So you might only be able to get 30 or 40 megabytes per second off of your SSD in a single query because it's busy also doing all the other stuff that the query has to do. So this is a typical OLAP example. The company has a star schema. I focus a lot on star schema because that's the schema that works best with ShardQuery, 1 or 2 very long tables and a bunch of smaller lookup tables. So I'll give you a bunch of use cases later on, but for business intelligence, star schema is almost always used, so it works great. They like to present a sum total of orders for all time on the dashboard, right? So in the beginning, that dashboard is really fast, right? Their business doesn't have a lot of sales. But as their business grows and grows and grows, this query on the dashboard gets slower and slower and slower. And eventually it takes longer than the 24-hour refresh for the dashboard, and they no longer have, what happened yesterday. Well, what happened 2 or 3 days ago that they can focus on. And they can't make the business decisions that they need to make based on their data because their data takes too long to query. And there's not much you can do with regular MySQL at this point. Right? Your choices are very limited. So can we use caching? No. Caching doesn't help in this case because the query takes so long to run that by the time we cache the result, we have to already have another query finished running. Right? Materialized views probably could help here. Like I said, Flexviews has real materialized views. Problem with the materialized views are you have to modify your application to use them. Right? So you're going to have a special materialized view for this report, and a specialized materialized view for another report. And unless you use software like Mondrian that knows how to access summary tables automatically, then it's going to be a big problem for you. Right? So I love materialized views, but they're not a solution for everything either. Partitioning. Well, partitioning you'd think might help. Right? Partitioning, we're talking about splitting one big table to lots of smaller tables inside of the database transparently. In Oracle, when you add partitions, you automatically get parallel query. All the partitions can be accessed in parallel, but not with MySQL. With MySQL, the partitions are accessed serially. Thus, it doesn't help you at all in this particular case. In sharding, well, sharding will help, but your application has to know how to put the results back together again, which is what ShardQuery does for you. Right? So sharding, yes, but typically not unless you put some work into it. So ShardQuery, its goal is to make OLAP queries more like OLTP. Instead of having one big query that accesses just one table, we're going to break it up into smaller queries that can access these smaller tables in parallel. So you can use both partitioning and sharding to keep the data size for your queries to a minimum. So for example, if your table has 16 partitions, with ShardQuery, you can get up to 16-way parallelism, right? If you have 2 nodes and 16 partitions on each, that's 32-way parallelism. So if you don't want to use partitions, you can also use multiple schema on a single server, right? It's sharding. That way you don't use the partitioning option. For example, InfoBright, which I'm going to talk about a little bit later. It's one of my favorite storage engines. InfoBright doesn't support partitioning. So in that case, you'd create 4 different databases, or 8 or 16 different databases, and spread the records over all of them. Any questions so far? Okay. So a sharded database has multiple nodes or databases, and they're each called a shard, right? It isn't like a shard of glass, right? Like I said, it's a portmanteau of shared nothing. So it's possible for one physical host to host many shards. Every shard has identical schema. So when you run a query, you get the same view over all of your nodes. You don't want to have a situation where some shards have more columns than other shards or whatnot. If you do a select star, you'll get very inconsistent results. So the shards work together to form one virtual RDBMS. In ShardQuery, it's called a virtual schema. So all of these different shards work together as one big shard. You can think of the shards, since they each have a small piece of the data, all the shards together are like a union all, right? So you put all your shards back together to get all of your data. I mentioned it before, the shard key. And the shard key is how ShardQuery figures out where data goes in the system. So we can use hash-based or directory mapping, but the shard key is what configures that. So there's usually 1 or 2 really big tables, like the user activity log, or the sales table, or some other large table. These are called fact tables in BI parlance. So you might have blogs, and blog posts, and blog comments. And those all contain the blog ID. And we specified the blog ID as the shard key. So every, if we take blog 30, for example, all the row 30 rows and blogs, blog posts, and blog comments will all be on the same machine. That way you can join those tables together, no problem. So you can join sharded tables together, and you can join sharded tables to unsharded tables. So usually you have one pretty big table and smaller lookup tables. Picking the shard key is the most important decision that you're going to make when you use ShardQuery, because it's how it figures out where the data goes. If you pick the wrong shard key, your data is not going to be distributed evenly over all your shards. So just like when you pick a partitioning key, pick a shard key that is going to lend itself to sharding your data. The sharded tables contain the shard key, and the unsharded tables don't contain the shard key. And that's really how ShardQuery tells the two apart. If you insert into a table that has the shard key, it will go and map the row properly and send it to the right row. If it doesn't have the shard key, it gets sent to all of the shards. So like I said, the rows for a specific shard key are all co-located on the same shard. Does that make sense? So one of the optimizations that ShardQuery has is called shard elimination. It's the analog to partition elimination. So if you do a lookup, you do a where blog ID equals 30, ShardQuery will look at the directory and figure out that shard 30 is, or blog 30 is on shard 3, and go to the right place. So where blog ID equals 10, for example, we'll just send the query to the right place. Equality lookups are the most efficient, and so we're going to try to use those, but you can do in between. But you're not allowed to use subqueries. That's one of the only places where subqueries aren't allowed in ShardQuery. So in general, I don't use this feature very often because most of my queries are analytic queries that hit all the shards. But if you need to go look for specific data for a specific user, no problem, you can do that. This differs from MySQL Fabric. MySQL Fabric, you have to add metadata to the query and tell it to which shard to go to. And it can only go to a single shard. This with an in can go to 3, 4, 10 shards, whatever. So can ShardQuery help on a single machine? And the answer is yes, it can. Use partitioning, MySQL partitioning, to split one big table up into the 3 or whatever smaller tables internally. And if you have lots of partitions, then ShardQuery can use lots of cores to answer the query. Right? If you have 8 cores and 3 partitions, you can use 3 cores to answer the query. Very similar to Oracle. So how exactly does that work? Well, ShardQuery takes, and after it rewrites your query, it sends an explain plan to the server. And the explain plan says which partitions are going to be accessed. So if 1, 3, and 5 are going to be accessed, and ShardQuery can write a query against each one of those partitions. And I'll show you an example of this in a little bit. So the explain shows what partitions are going to be used. ShardQuery says, okay, I'm going to access those partitions in parallel. It uses the new 5.6 partition hint to access the right partitions. So this means that it works with hash or key or range columns or list columns or whatever type of partitioning you use. It doesn't matter. It can access all the partitions individually because of this new 5.6 feature. ShardQuery does work with 5.5, but you probably want to use list columns or range columns. Those are the 2 best methods to use. Of course, you could shard this instead, right? Instead of having 4 partitions, you can have 4 servers. And each one has a copy of the blogs table. And there's some blogs on this, and some blogs on this, and some blogs on this. When you do account star, ShardQuery will do account from here, account from here, account from here, account from here, and it will combine those counts together at the end. So it actually turns sum into, or count into sum at the end. Mm-hmm.
When you're doing that partitioning, are you separating each one of those containers to get into different rows? Are you separating horizontally or vertically?
Horizontally. Okay. So this has some subset, this has some subset. But you can do sharding and partitioning, right? So here we get 4-way parallelism from 4 shards plus 3-way parallelism from 3 partitions on each shard to get a total of 12-way parallelism. 4 times 3 is 12. So this is really, really cool. So all you need to do is really split up your data internally or on multiple shards, and you get automatic parallelism. There is a configuration repository. It's a special database that contains all of the configuration for ShardQuery. In the past, ShardQuery was configured with an INI file. You would have to copy that INI file to every node, which was inconvenient, especially if that happened to differ on one machine than another. So now instead, it uses this configuration database. You should try to make this, but ShardQuery can be completely HA, right? Each of the shards can be an XDB cluster or use DRBD or whatever you want to do to make them redundant. Gearman itself, which we'll talk about, can also be redundant. And as long as you use something like XDB or replication for this configuration repository, then it's redundant as well. You can use ShardQuery's web interface to change the settings in the config repo, or you can just use SQL and update the schematic config table. Like I said, this really makes ShardQuery easier when using lots of nodes because you don't have to keep that INI file in sync anymore. So I know these slides are kind of ugly. I apologize. We have the 3 main ways to run queries in ShardQuery are the object-oriented interface, Apache interface or MySQL proxy. Communication is Gearman. Workers are the processes that actually do the work. And then the storage of MySQL database shards. I'm going to go through each of these. So Gearman. Gearman is very important. Gearman is an anagram of manager. It's a job server for PHP, Java, Perl, C. You can write workers in any of those languages. These are all, of course, written in PHP. It provides a parallel mechanism for ShardQuery. Right? So like I said, Gearman supports asynchronous jobs. You send it, ShardQuery might send it 20 queries. Once all those 20 queries finish running, the results come back and you get them. Gearman lets us do a kind of MapReduce, right? So going and running the select queries are maps, and then bringing the results back together at the end is a reduce, right? If a job comes in and all the workers are busy, it queues, right? So that prevents the server from being overwhelmed by queries. So this is just the little graphic from the Gearman homepage. Right? So ShardQuery up here is the client application code. It talks through Gearman. Down here we have the workers that ShardQuery uses. And I'll explain each of those. So there's 3 different kinds of workers. There's the loader worker. The loader worker listens for loading jobs. Makes sense. ShardQuery has a parallel loader. You can take and feed a text file into the loader. It does a pass over the file to figure out where the chunk boundaries are. Then it submits jobs through these loader workers to load the various 16 megabyte chunks of the file in parallel. The ShardQuery worker listens for SQL. It runs that SQL via ShardQuery, and it returns the results in JSON. This is the worker that the proxy uses. And the store result set worker, it's also the worker that the web interface uses because it's asynchronous. And the store result set worker is the main worker. This is the one you're going to see doing most of the work. It runs an SQL statement, and then it inserts its results into a table. So when we get a shard from, or a query from 5 different shards, there's 5 different store result workers that run, and they return their result into the same table. It's what we call I call it the final aggregation table, but it's the reduce table. The object-oriented interface is very simple to use. I'm going to give you an example in a moment. Usually you don't even need a constructor. If you don't pass a constructor, it'll read the config file, it'll go look up into the configuration repository to get the configuration, and it will load it in. So all you do is just new ShardQuery, ShardQuery query. There's just one function to get the results. Now the complete example here to use this interface is in bin run query. That's the little utility that comes with ShardQuery that just uses the OO interface. So you can get that as a full example. This is a small snippet of that here. You can see new ShardQuery, ShardQuery query SQL. Here we just check for errors. And here we iterate over the result set. So ShardQuery comes with its own data access layer called the simple data access layer. So underneath the covers, eventually ShardQuery will support more than just MySQL. And so the data access layer just abstracts the access to that statement handle away. That make sense? So the web interface is the GUI, right? It's very easy to set up. It comes with a config file. You just copy it into your Apache setup, and you're pretty much done. It runs queries, gets the results, displays them. This shows you how to use ShardQuery in a web app with asynchronous queries. So this goes through Gearman. And it just comes with simple HTTP authentication. You can run the set password script that comes with ShardQuery to change the password. MySQL proxy. So this is the Lua script for proxy. Unlike the other interfaces, it supports most show commands. So you do show databases, and it'll show you your virtual databases that are set up. It intercepts the query. It sends it to ShardQuery using the Gearman UDF, gets the results back as JSON, and sends it to the client. So as I said earlier, it behaves a little bit differently than MySQL for some commands. Like insert, it returns a result set that you don't normally expect from inserts, but it won't break anything, or it shouldn't. So as I said, it's got a MapReduce-like workflow, right? So we submit our query, then we parse the SQL. The SQL parser is PHP SQL parser. It's a parser that I wrote specifically for ShardQuery. It's used by Sugar CRM. It handles all selects. It even handles things like for update. For update or with rollup. Right? So it supports a wide range of SQL commands if you want to use it in your own projects. The query rewrite mechanism, right? So ShardQuery works by rewriting your queries. As I said, when you do a count, it has to turn that into a sum of counts. So that's done by the rewrite layer. Some other things, semijoints. If you use an in subquery, it has to run the results of the subquery, put it into a temporary table, turn that into a join to the original query. All aggregate functions except group concat are supported. I haven't tested group concat in a while, so I'll exclude that. But all the aggregate functions will be rewritten so they can operate in parallel. Right? So variance and standard deviation are turned into sum of the column, sum of the column squared, etc. So they can do standard deviation and variance. And very, very useful, it does push down limit whenever possible. So as long as you're not doing something like count distinct, it's going to be able to push down the limit. So because the lookup tables are on all of the shards, we can join to lookup tables with no problem. So everything is shared nothing. The join, the filtering, the aggregation, it's all pushed down to each individual node. That means very little data has to go in between the nodes. So I did a test with 200 gigs of data against Amazon Redshift. I used machines that were 1/3 the cost of their machines, and performance was about the same. For those queries that were slower, I could use more powerful machines for the same amount of money and get the exact same performance. Now, it is important to note that ShardQuery does differ from Redshift and Greenplum and Vertica in that they don't have the concept of a shard key. They have a data distribution that's configured per table. So they can join two really huge tables that are sharded, for lack of better terms, together, which ShardQuery could not, because ShardQuery can only join tables where the shard key is the same. So they're a little bit different, but for most use cases, you can get away with ShardQuery. Then Gearman, right? Gearman, this is MapCombined instead of MapReduce. It's because these queries will use on-duplicate key update to update the rows that are in the coordination table. So MapCombined, the store result set worker runs SQL and stores it in the table. Like I said, to keep the number of rows in that table, and thus the time at the end, small, it uses insert on-duplicate key update. And the key in the table is whatever group by you specify, right? Because each group by attribute appears only once. So to get the final result back, it's got to combine the results from the other queries together. Like I said, count, it's turned into sum. Then the aggregated result is returned to the client. You can see that. This is a ShardQuery explain plan. You'll see I ran run query. That's the example that comes with ShardQuery. -- verbose. When you run with verbose, it'll tell you what it's going to do. I didn't have any rows in this table, but I did have the table partitioned. So we get 4 queries. Notice they access P0, P1, P2, and P3. Those are the 4 different partitions that are on the table. It runs those queries. Then, finally, it sends this coordinator query. Right? Select sum of the aggregate function as count from aggregation temp 58392079. Here, we didn't actually have any results, but that's the way it does. Does that make sense? This is an example where it can actually do the map combine. It's select LO order date key count star. It turns LO order date key into expression $0. It deduplicates the expressions in your query. So expression 0. Expression 0 is going to be used for the unique. And here's the on duplicate key update. So it says that the sum is equal to the value plus the new value. So instead of having one row per shard, we'll have 1 row per group by attribute. Make sense? Like I said, this isn't a very long presentation. I apologize for the shortness. But we have lots of time for questions. So this is really good for machine-generated data. The Internet of Things, right? Everything's collecting metrics about everything now. So sensor readings, metrics, logs, essentially any big table with short lookup tables. In star schema, it works great. ShortQuery is used by the billing system of a large cellular provider called Ericsson. I think you've probably heard of them. So they do billing. The CDRs, called detail records, generate lots of data. And they use ShardQuery's built-in percentile function. So it comes with a percentile aggregate function. You can write your own custom aggregate functions for ShardQuery. And percentile is just the example that it comes with. Green energy. So this is a company in India. They're collecting metrics from smart meters that they've installed in Indian homes. And they have lots and lots and lots of customers. And so they bulk load their metrics data once a night, and then they run reports on it. In ShardQuery, they can go and report over all of the shards instead of having to go and manually put all the results back together again. So they're using it for a green power grid. There's another company that's using it for log analysis. So they collect performance logs. I have another tool called Instrumentation for PHP. Generates a big, huge table full of metrics. They aggregate that and process it. And they also just load the raw text files into their system, and they use like on them, or regexp, and they do that in parallel. So this is just a quick example. I ran this yesterday just to refresh these slides. This is this star schema benchmark. It's scale factor 20. So there's 119 million rows of data. I used InfoBright. I like InfoBright a lot. They're a column store. You get much better I/O than you do with a row store. You also get very good compression. This is 12 gigs of data. It fits into 1.2 gigs, 10 to 1. Now, there are 4 different flights in the star schema benchmark. I just picked the first query from each because it's the longest query, just to show how things work. And what I did is I took an unsharded system. So I just loaded all the data into a single table and the dimension tables, and I ran it. And then I compared that with 4 shards. So I split the data over 4 machines. Well, actually, it's only 1 machine. I split the data into 4 different schema. Right? So I created 4 partitions, 4 shards. Query 1. Right? Select sum, LO extended price times LO discount as revenue, blah, blah, blah. Pretty simple query. Just a 1 join. MySQL cold, 35 seconds. ShardQuery cold, 11.62 seconds. So not quite 4x, but this is on a single hard drive, so I didn't have the I/O to drive it. Hot, MySQL 11 seconds. ShardQuery, 2.95. Pretty big difference. Query 2 is a little bit more complicated. It uses joins to multiple tables. 34 versus 12, and 12 versus 3.26. So that's about 4x. Here, query 3, hitting all the tables again. 7.9 seconds versus 27.29 seconds, so about 4x. And 5.06 versus 18.89, so not quite 4x. Yes. Yeah. Sorry. Well, InfoBright's just a MySQL storage engine, so I just unsharded versus sharded. And same here, 8.4 versus 23, about 4x, and 4.29 versus 14.77. And that's all I have to say. I think I covered all of the...
I don't know cold hot.
Oh, the query, the database just reset. Cold, not in the cache. Hot, in the cache. Yeah, I just ran the query once, and then ran the query again. Take the two numbers.
How do writes propagate through this?
There's two ways. You can use the loader. So the loader loads a delimited file. So you can just load your data up in a CSV or a pipe separated, and just load the data that way. And that's the parallel loader. So what you can do is you set up a shared file system, like an NFS or a CIFS. You put the files onto that. Then the workers all access the same shared path. So they all point to the same place, and the distributed loaders can access the files and insert. So you can have workers, you can have dedicated loading machines if you want. If you just run inserts, the insert's parsed and goes to the right node. You can do also multi-value inserts, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3. So yeah, that's pretty much the way the data gets moved around.
I'm assuming it's appropriate for more of an online, not an offline
It-
load. You can use a nice production environment where you're sending a lot of writes into it.
You could, but the writes have overhead because they have to do the mapping. So you just have to have enough machines to offset that.
What are the Gearman workers run, and generally how many do you run per node?
I generally run one per core, and I generally run them on, you can run them on the machines themselves, on the shards, or you can have a dedicated coordinator machine. Yeah. By default, what it does is it picks one node randomly to be the coordinator machine. But you can specify that certain machines are only coordinators. 119 million. Yeah, 12 gigs. InfoBright's pretty fast. Those numbers would not be that low if that was line InfoBright. Oh, there's a yeah, especially for analytics, for OLAP, InfoBright is going to be faster. One of the reasons that InfoBright is faster, besides the reduced I/O and the compression, is that it has a hash join. And MySQL uses nested loops. So hash join typically will outperform nested loops when you have to join two large amounts of data together. No, there's table level locking. So yeah, if you use the Enterprise Edition, I believe so, but not the Community.
Are there any result size limitations? So you do a select star on a giant table?
It would just fill up, it could fill up your coordinator, but it all goes into that coordinator table, so there's no result set limit size. Yeah, you definitely don't want to do select star from big table. Well, it supports range-based, not hash or directory-based. So my plan is to make the ShardQuery mapper is extensible. It's an object. So it comes with the hash mapper, the directory mapper, and the none mapper. The none mapper by default doesn't do anything, but you can override it, you can extend it, and so what I want to do is make it read ShardQuery, read Fabric metadata and be able to access a fabric through ShardQuery. That way you can insert all of your rows and count them too.
You said with the directory versus hash, since you can't rebalance essentially with the hash, update that directory, where is directory live?
Oh, it lives on the config node. Yeah, that's part of what it considers its configuration. Yeah.
How does ShardQuery handle transactions?
It doesn't. Yeah, you could run one on each of your shards.
You said earlier that ShardQuery can rebalance the shard based on the shard, right?
You can do it manually, as long as you're using the directory.
Okay, so but it doesn't support handoff.
No. What you would do there is, I mean, I don't trust, the reason it doesn't support XA is because MySQL's XA is broken with the bin log. If you have a prepared transaction and your database crashes, and you commit that prepared transaction after the database comes up, the changes don't go into the binary log. They're lost. So that's a big problem for XA. I can make it supported if people want it. But what I would do is I'd start an XA transaction on the original node, an XA transaction on the new node, and an XA transaction on the directory. Then under that XA transaction, copy nodes from the old machine to the new machine, update the directory, and then XA commit, and all through.
Okay, so it's totally outside, but still ShardQuery.
Right, that's a manual process. I don't have automatic shard splitting implemented. It's close. There's two configuration scripts you have to run. The first sets up the config repository, and the other one sets up your virtual schema. So once you do that on one node, on all the other nodes, you just run the point at script and point at directory script to point them to the directory, and they'll write their own new config file. So you don't really have to do much of anything. It's pretty out of the box, straightforward. Just to set this up, it took me 25 minutes. That's included installing all the MySQL and everything else. It's pretty simple. What you do to install it is you create an initial INI file. I don't have an example here, but you just populate. Yeah, that would work too. Question, Ryan? I'm not sure. See, the SQL parser is awesome because I no longer maintain it. It's one of those open source projects that I wrote, and then somebody else said, "Oh, I'd love to work on that," and I let them. So the SQL parser itself is pretty complicated, but it's only 1,000 of that 10,000 lines probably. Yeah.
All the shards are always equal in terms of like divided, the database is divided by the number of shards.
Yeah, you want to pick a shard key that's going to evenly distribute your data. Otherwise, you'll have some nodes that have too much data, and your queries will run slow because that one node will take a lot longer to finish. Right? It's like RAID. You're as fast as your slowest server. It's basically RAID for databases. Anything else?
How much does the number of shards affect the performance overall? Have you played it, like with this, for example? I would think that the number of shards you actually have is going to have a big effect on performance one way or the other.
Well,
Clear me which way to go with that.
as long as you have enough workers to run queries on all those nodes, the bottleneck is going to become that central table. Right? So if you have lots of shards and you've got lots of rows coming back from those shards, then it's going to be a bottleneck. With most queries, since they're aggregate queries, they return a small result set. And so the result set still stays small. You can choose the type of coordinator storage engine to use. So you can use MyISAM or InnoDB. If you use MyISAM, you'll have a row level lock or a table level lock while each node inserts. It's a default, but usually it's okay. But you can also use InnoDB. Matter of fact, I actually turned off an optimization in ShardQuery. It used to send order by null to the shards, but that would come back, the rows would come back in random order, and I wouldn't be updating the coordinator table in sorted order anymore, and I would get deadlocks. So I had to fix that. Yeah? No. And Apache is only used for the GUI. Yeah. It's like MySQL_d_safe. I have a safe script for each of my workers. So if a worker dies, it just gets restarted. So you just run ./start workers. It detects the number of cores in the machine, and it runs one worker per core. Generally, I envision ShardQuery for data sets that grow rapidly, but are mostly append only. So if you're collecting logs or user activity, stuff, or even metrics from various sensors, those are mostly insert only. And so when you fill up a shard, you just add a new one and start filling that one up. If you want to manually split them, it's going to be a manual process, and you'll have to update the directory. But you can do it pretty easily. You could just use like my SQL dump with the -- where and pick out only even rows, and then just go update the directory and move the rows to a new machine. If someone wants to pay me to do it, sure. It's one of those things that it's, what's that? Needs to be more than a couple slices of pizza, Ryan. No, it's something, I did originally have a shard split script, but ShardQuery got a little more complicated and I didn't maintain it. So it's something that I can do, I just haven't done it. And I mainly didn't do it because of that XA limitation. I mainly didn't do it due to the XA limitation. Okay, well, thank you. Oh, and my email address isn't on here, but if you want to write it down, it's greenlion@gmail.com. I'm a big Voltron fan. I didn't, but that doesn't mean anything.